Learning. So, as I mentioned in the introduction video, my name is Lucy D'Agostino McGowan. You can find me, my email is mcgowld@wfu.edu. And most of our questions, I'm hoping that you'll use Canvas, the discussion board, to post most of your questions about this class. That way we can sort of all collaborate and get the answers collectively so that if someone else has the same question, we can come to that together. And as I mentioned, I am going to be offering extra participation points for sort of contributing in that manner. My email, you can use that if you have a personal question or if you have a grade-related question. And I'm going to be offering office hours 4 times on Tuesdays and Thursdays, 9:30 to 10:45 and 12:30 to 1:45. And there's 2 ways you can do those office hours. The first is via Canvas chat. And so I'll be monitoring those live during that time if I don't have appointments booked via Zoom. And the second way is via appointments in Zoom. And so you can book 15-minute appointments to discuss a specific topic. And when you do that, you'll go to the office hours thread on Canvas in the discussion and see if anybody else has already booked an appointment to discuss the topic that you're interested in. And if they have, go ahead and join that session. And if they have not, then you can go ahead and book an appointment and make sure that you add a tab or a thread on that office hours discussion post so that I know what topic you're coming to discuss and what time you're planning on coming. So we're going to see how this works. I'm definitely flexible, and if this seems to not be working well for folks, we can definitely come up with new solutions. But this is what I am planning for at least the start of the semester. Okay, so everything you need is going to be posted on this website, bit.ly/STA363F20. But as I mentioned in the Canvas walkthrough, in addition to having everything here, I'm actually going to outline step-by-step what you need to complete before class, during class, and after class on Canvas. And so Canvas is going to link directly to the parts of the website that you need as you need them. And so as a one-stop shop, you can basically focus on Canvas as the one place to look for information about this class so you don't have to be sort of bouncing around all over the place. However, you're also welcome to, of course, use the class website directly if you'd like. Okay, so let's talk about some statistical learning problems to sort of think about what types of things can be solved with the tools that we're going to learn about in class this semester. So here's one that's really common. A very common problem that is solved with statistical learning is trying to identify risk factors for a particular disease. For example, identifying risk factors for breast cancer, you can use statistical learning techniques to be able to figure out what those risk factors are. Another very common application is customizing an email spam detection system. So the example data set here is 4,601 labeled emails sent to someone named George who works at HP Labs. And so here the input features are frequencies of words and punctuation. And you can see in this table the frequencies among those that are classified as spam and among those that are classified as email for each of these couple of words here for these 7 words. And that can sort of help you build a model to predict if you got a new email, whether it was spam or not. So just looking at this table, if I were to build a model just kind of mentally, if you can notice in this first column, George is the word of interest, and 0 of the emails that were classified as spam had the name George in them, and on average about 2.2, the emails that were true emails had the word George about 2.27 times on average. And so that would suggest that a pretty good classifier might be to just check if the email has the name George in it, and if it doesn't, then if it does not have the name George, then you might not be quite sure what to do with that information, but if it does have the name George, then you can probably classify it as not spam or as email. The next is the word you. That one, it looks like the word you is used much more often in spam than just in regular email. So on average, the word you is used about 2.26 times in spam and 1.27 times in email. And so for each of these words, kind of using the combination of all of this information, you could build a predictive model that could easily help you classify emails into one or the other category. So this classification task is a really common one in statistical learning. Here's another one, and this one has a little bit to do with image processing. So in this case, we're trying to identify numbers in a handwritten zip code. So this is a very, very common problem. Every time you mail a letter where you've written out a full address, including a zip code, when that mail is getting classified, rather than having an individual try to look at every single zip code and classify it by hand, a machine learning algorithm or a statistical learning algorithm could help with that. And so just looking at these numbers, you can sort of guess about what differences would be really easy for your model to detect and what might be a little bit harder. For example, distinguishing between a 0 and 1 is a pretty easy task for a machine learning algorithm or a statistical learning algorithm. If you treat each pixel of these images as an individual data point, you can see that between 0 and 1, there isn't a lot of overlap in the pixels because zeros have a big gap in the middle and ones tend to kind of fall in the middle and have pixels right there. So those are pretty easy to distinguish. But if you're trying to distinguish between a 1 and a 7, it might be harder depending on how people are writing it. And so building a really robust model that can sort of help you with that prediction can be really useful for saving time and also for doing another classification task that's a little bit harder than just customizing an email spam detection system. Another common problem is establishing the relationship between variables. For example, you might want to establish the relationship between variables in a population survey. And so this plot here is from income survey data for males from the Central Atlantic region in the US. This data was collected in 2009, and it's looking at the relationship between age and wage. And so you can see from this purple line that's sort of drawn through this cloud of points, that's the prediction model that was created. And it looks like that there is a relationship between age and wage, and that relationship is kind of like an upside down U shape such that young folks and older folks are making less money, so they have a lower wage, and people in the middle have a higher wage. And so being able to understand the relationship between variables, that is another use of statistical learning. Classifying pixels of an image. So this is a similar problem to the handwritten zip code problem, but a little more complex in that rather than just having black and white numbers, here now we're trying to classify into more categories. And so this particular picture, we're trying to classify land into categories: red soil, cotton, vegetation stubble, mixture, gray soil, and damp gray soil. And so by being able to process these images across various spectral bands, we could sort of try to guess what the land use is. And so this is another very common problem that machine learning or statistical learning tries to solve. And so there's two types of statistical learning. There's supervised learning and unsupervised learning. And this class focuses primarily on supervised learning. There's another class offered here at Wake that focuses on unsupervised learning that you can take or maybe have already taken. And so in the supervised learning setting, you have an outcome variable. Often we denote this as Y. Some other terms for this variable are dependent variable, response, target. And then you have a vector of predictors. So you have P predictors, and we often denote this as X. And these are sometimes called inputs, regressors, covariates, features, or independent variables. And so there's two types of supervised learning problems. The first is what we call a regression problem. And so in this case, Y, your outcome variable, is quantitative. And so by that I mean it's numeric, it's continuous, something like price or blood pressure. That would be a quantitative outcome variable. The other type of problem is a classification problem. And so in that case, Y takes on values in a finite unordered set. So that would be something like whether someone survived or died, or the digits between 0 and 9 for that zip code classification question, or you might be trying to classify the cancer class of a particular tissue sample, something like this. And so the way this works is we have training data, which are basically pairs of these X's, and so these predictors, and Y's, these outcome variables, for a number of observations. Sometimes these are called examples or instances of these different measurements. And so we want to use this training data to try to inform how the relationship between those predictors and the outcome variable y. Okay, so what do you think are some objectives here? So the main objectives, at least the ones that we're going to be talking about in this class, we've got 3. So the first would be to accurately predict unseen test cases. And so that would mean basically we've got some training data and we want to use it to predict some new test cases. So in the case of the zip code data, you may have a whole bunch of handwritten numbers, and you could use that, you can turn that into a data set where a human classifies them correctly, and you use that training model to help a machine be able to later classify correctly some new data. Another objective is to understand which inputs affect the outcome and how. And so this is like that wage and age data where we were interested in the relationship between age and income or wage. And so understanding which inputs that you have or which predictors affect the outcome, and also understanding the shape or the relationship between those predictors and the outcome can be an important objective here. And then finally, you want to be able to assess the quality of our prediction and inferences. And so we'd like to be able to accurately predict those test cases, and we'd also like to be able to maybe figure out some inference or be able to draw conclusions about which inputs affect the outcome and how. But once we've done both of those or one of those, we want to be able to assess how well we did it. So assessing the quality is also really important. So unsupervised learning, just briefly so we can sort of have a sense of what it is, even though it's not going to be the focus of this class, this is where you don't have an outcome variable, just a set of predictors or features that are measured on a set of samples. And so the objective here is a little bit more fuzzy. Essentially, you're trying to find groups of samples that behave similarly, or find features that behave similarly, or maybe find linear combinations of features with the most variation. And this is going to sort of help you sort of classify certain samples, but you're not actually associating those classifications with a particular outcome because there's not an outcome variable in this case. It can be difficult to know how well you're doing because you don't have that outcome variable to sort of gauge your accuracy and things like that. And this is different from supervised learning, but it actually can be really useful as a pre-processing step for supervised learning, and we may talk a bit about using these types of tools for pre-processing along the way. Okay, so let's go. Now we're going to do a quick exercise together. So the first thing I want you to do is log into RStudio Pro. And so for this class, we're going to be using RStudio Pro to be able to use RStudio, which is the interface we're going to use to be able to run code in R. And so I want you to be able to both, in addition to kind of getting this very strong theoretical grounding, I want you to be able to immediately apply those concepts to real-world data. And to do that, we're going to use R. And so to get into RStudio Pro, you're going to need to use VPN, a VPN to connect. And so go ahead and get that set up. You can do that through Wake. If you just Google VPN WFU, you should be able to find it. Or if you go to the slides for today, you can click on this link I have right here to get your VPN set up. And once you've done that, you can click on this link, rstudio.hpc ar53.wfu.edu:8787, and that will bring you to our RStudio server. Your username is going to be your Wake Forest username, which is typically the first part of your email, and the password is R2D2 star. So while you're doing that, I'm going to do it as well so you can see what it looks like. And so when you go to this URL, rstudio.hpc.ar53.wfu.edu:8787, you should come up to this screen to sign in. So I'm going to sign in with my username, McGow-LD, and the password is capital R, 2, capital D, 2, capital S, T, A, R, exclamation point. All right, so when you sign in, depending on if you've used this before, RStudio Pro or not, you may see this screen where you get to basically a main screen here this is what RStudio looks like, and this is what it looks like on the server. It looks the same. So you may see this. If this is what you see, go ahead and click on this blue RStudio server home icon. Or alternatively, if this is your first time joining RStudio Server Pro, you may see something like this. And so we should all be back at this place now. So if you don't see this kind of main screen version, go ahead and click that blue circle at the top there of your RStudio session. And what I want you to do is I want you to look in this projects, and I want you to find a project called 01-welcome-penguins, and I want you to click that. And that's going to open this up. And that should bring you to this session where you can continue on with the instructions on the next slide. Okay, so hopefully you've all logged into RStudio Pro. Go ahead and pause the video if you haven't yet and get that sorted out. I've put on Canvas in your what to do after this class, I've put a little assessment to just check a box to let me know if you got all set up in RStudio Pro, and if you're having any problems, I've got a space for you to add comments so that we can try to troubleshoot that together. We're going to need RStudio Pro for a lot of the exercises we're doing, in particular the way that I'm going to be doing labs in this class. You need to have access to this so that we can collaborate across students. So make sure that you've got this set up. You don't want to just use RStudio on your local computer because we want to have that ability to collaborate across students. Okay, so once you've logged into RStudio Pro, find that project 01 Welcome Penguins and click it. And then in the Files pane in the bottom right corner, you should see a file called welcomepenguins.rmd. I want you to open it, and then I want you to click on the knit button. See if you can find the knit button yourself. It's going to be somewhere along the top. And then I want you to go back to the file, and I want you to change your name on the top in the YAML, which is something we'll talk about what this means later. And then I want you to knit it again. And then scroll to the plot chunk below the title Palmer Penguins and do some code editing. So instead of looking at the relationship between flipper length and bill length, I want you to plot the relationship between flipper length and bill depth. I've included a full data set at the bottom of the document for variable names, and so once you've knit that file, you can look through that data set at the bottom to be able to decide kind of what variable names you should be using for this new plot that I'm asking you to make. I'd like for you to also update the captions to match your new plot and to knit it again. So this should take about 5 minutes. I'm going to go ahead and set that timer. You can go work on that. If you need more time, of course, you can just pause the video.